a co-host. So maybe you can. Thank you. So now I can share and hello. So for those online, well, let's wait for a couple of minutes and then we will start. And but I can go ahead share my screen. Okay, so I think this will be good for now. Actually, so let me plug in my power adapter. Me. All right. So it looks like most of you already got the pizza, and then so we can start, I guess. And yes, if I could. All right, so where's my slides? Why it doesn't? Oh, I know why. Low, so. Okay, go. Interesting.
If you just got here, please check your email to actually check into the event. It's a link from Major League Package.
Okay, so interesting. Usually I could use my iPad to control my slides. That's the really, it is the only reason why I use the Apple page for the, is that page? Keynote for the presentation. But yeah, I don't know why I cannot do it today. So well, it won't be a big deal. Well, unless I need to draw something later, but I can, well, let me try one more time. I think there will be some setting I need to do. So if I cannot figure it out for this try, then I will simply skip that. Okay, seems I can this time. So, all right, pretty cool. Okay, so now we can start. And so, sorry, so well, hello, I think I know most of you. So yeah, so many familiar faces. And so, well, I'm Tony Liang. So I'm a assistant professor at the Computing and Cyber Security. Yes, Computing and Cyber Security Department. And my research is focusing on machine learning and deep learning in particular. So yeah, I'm very excited on this topic. And well, many of you probably know that. So it will be a series of 2 events, 2 workshops. And so the next one is after the spring break. And for today, I have 2 parts planned. One is I will give you a general introduction to the field, to machine learning, and so what they are, there are lots of buzzwords, kind of confusing, and then people use them mix together, and then yeah. So also seems AI machine learning can do whatever, but really what it can do, it cannot. So it will be the first part. Then the second part, I will focusing on one learning algorithm, which is linear regression. So many of you probably know that. I'll have some basic understanding of linear regression. So I will have two demos. One is just from the very low level. Okay, so it will show you how the algorithm actually learning things. And then another will be use the high level API of our libraries, and then building machine learning model for linear regression. And so I consider linear regression, especially, so I will talk about that later. So especially another form called logistic regression. It's just a excuse me, the building block of neural networks. So yeah, which is the next thing I'm going to cover in next workshop. So I want to give the basic introduction today. And I think that's good enough for the introduction. And well, actually, let me stop sharing and then go to my, so I pre-made a little video there, but I just checked, I could connect to this server. So just curious, how many of you use the ChatGPT before? Okay, and how many of you use it for assignments or quizzes or plan to use it? No, not yet. Okay, so well, if you use, I will not tell anybody. And then, so yeah, for those who are not familiar with ChatGPT, well, let's play with it. Okay, so looks cool, and okay, so I don't know what it will say. So of course, I'm ChatGPT, the language model, okay, developed by OpenAI, and quite a bit. Okay, cool. Okay, so cool. Do you know math? Yes, I do. I have programmed to understand and solve mathematical problems. Okay, cool. And let's see. Okay, so I just typed in bunch of random numbers. I have no idea what I entered, but okay, so looks like ChatGPT does give us an answer. But let's verify that. It may get correct or may not. Okay, so got chat. Okay, so all right, so this is the answer Google gave us. And then, so what is the answer? 315. Okay, so looks like they are not consistent, right? So this is the Google gave us, and I pretty much trust Google. So let's see. Okay, so let's see what ChatGPT will say. Okay, well, yeah, thank you. So let me try it again. Okay, so another answer, which is different from the previous one. And so still not the same, right? And okay, so okay, and well, okay, so let's see. Okay, so this is a different one. It's the first one, right? It's the same as the first one. Well, okay, so All right, so. Okay, so I'll write a market report for Apple. Okay, so well, I cannot write. Okay, that's fine. You know, as an AI model, I cannot access current future market. Okay, that's fine. So how about this? How about now? Write a market analysis.
22, maybe that's pretty clear.
Well, okay, so it's a good suggestion, but let's see. So now I'm asking it to write a market analysis instead of the report. And well, let's see. Okay, well, so this time ChatGPT does something smarter, but okay, so let's try another one. So. I really hope if I cannot show you here, then yeah, I have the chat history with ChatGPT, so I can show it to you later. Okay, so it's getting smarter and smarter every day. And okay, so well, let me go back to the history. I think it was this one. So I just played with ChatGPT. This is this one, or maybe this one. Yes. Okay, so almost there, almost. So I asked, okay, cool. Yeah, this is the thing I want to find. So this is the report ChatGPT gave me yesterday. Okay, and it does include a number for 2022, and the revenue is 365 billion. Okay, I don't know whether this revenue is correct, but I know this number is completely made up because so remember this is the revenue for 2022, right? And if we go back to ChatGPT, so let me show you why. So, okay, yeah, that's fine. As AI, I don't have the real-time event. Well, so I don't know what happened yesterday. Okay, so what's the question? So when, well, I don't know what I want to ask. So okay, so well, I will go back to the history again because yeah, it may not give me the same one, so which is I think this one. Okay, so this is actually the training data for ChatGPT. And so the training data of ChatGPT has a cutoff to September 2021, which means any number it's given after this date is completely made up. So yeah, and then I think I have made my points. So there are two big flaws of ChatGPT. So well, it looks like great, right? So it generated a response very fluent and then smooth, fast. But one thing, ChatGPT doesn't know math, so doesn't know basic logic. And the second thing, the result could be completely made up, right? And so it's because ChatGPT is purely a machine learning model. Okay, and then the machine learning model at this moment, the output is built up based on the probability. So how ChatGPT can generate this paragraph? So it will start with the first word. So it calculates, okay, so there is a high probability the first word will be S. So generate S, and then from there, what is the next word could be? And then so get N, and then so just doing this to predict the highest probability of the next word. But of course, it does something fancier than this, but this is the basic logic. And then that's also why, so it could give a revenue for 2022. And because it's just a ChatGPT from the algorithm thinks, okay, so that there is a high probability will be this number. But whether it is or not, the algorithm has no idea. So, okay, and then I think that's all I want to show about ChatGPT. So we can go back to the slide. And well, ChatGPT is great, but so what is ChatGPT? Right, so this is the answer. ChatGPT gave me yesterday, and well, we can see it is so it is a neural network model and trained on vast, large, huge data set. And the next question, so how large is the data set? Well, actually, I have a little fun question for you. So, well, just make a guess, how much it may cost to train a ChatGPT? Any number? Yes, sir.
650 million.
650 million. Okay, and any other guys?
Around the billion?
Yes,
Billion?
billions, billions, billions. Okay, so, well, if for the rest, if you are wondering why the number is so high, and well, this is a device used to train ChatGPT. So it is only one simple GPU card. So it's A100 NVIDIA, and then the cost for each of those is this number, basically a car price, right? And so ChatGPT is trained on this, and then they OpenAI didn't release the exact number, but a reasonable estimation. So for only the training cost, without purchasing the hardware, without human resource, only for training, it will cost around between $5 million to $15 million for a single training. Okay, and then for a neural network model like this, they need to train multiple times. So which means it will cost a lot of money only on the training. So we are not cover any human salaries, any other things, only for the training cost. And then, so the reason is, and actually let me, so I wish I could move the Zoom, but I cannot. So this is also another thing bad with the keynote. And then, so another thing, because ChatGPT is trained on the huge data set, and how large we don't know, but it gave us, okay, so I will restart. So hopefully I can move the Zoom and then stop here. Okay. So yeah, let me, okay, so minimize this and then will it gone some, well, let's see if this will be right. Still block some, and hopefully later it will gone. So well, okay, yeah. So the how large the data set, ChatGPT didn't tell us, but ChatGPT is based on the GPT 3.5, which is the one version after GPT-3, and the GPT-3 was trained on hundreds of terabytes of data. And so this Mac has 2 terabytes of hard drive, which means hundreds of those Okay, and then so next question: how long it was trained? And I asked the ChatGPT the same question, and again it didn't give us the answer, but it said something about GPT-3, and it was trained on for several months on thousands of GPU cards. And I write something, it also an estimation. So ChatGPT possibly was trained on 10,000 to 30,000 A100 GPU cards, and it takes around 3 months. And so this is the reason why ChatGPT is so costly. And what I want to say for the next, but really just due to the large scale. So something like ChatGPT is actually not the thing we really concerned, because nobody can do that. Only Google, Microsoft, only those guys can do. And well, even they can do that. They know the algorithm is not as good as they claimed. How do I know that? Well, I work in the field, but here is also evidence to show you. And Google in 2018 already had something similar to ChatGPT today. And then they released the service, but I don't know how long, but then they decided to shut it down because it is not reliable. And then let's see, this is what Google announced in 2018. And so I'm going to maximize the volume, and then yeah, let's take a look. Uh-oh. No. Why it doesn't allow me to play? If it doesn't allow me to play, I have the URL there. It should allow me to do it and open the URL. Okay.
The progress with the assistant. As I said earlier, our vision for our assistant is to help you get things done. It turns out
the volume is too low. Let me have my little speaker, hopefully. And make sure I'm connecting. Okay. And increase the volume, and then let's see.
Part of getting things done is making a phone call. You may want to get an oil change schedule, maybe call a plumber in the middle of the week, or even schedule a haircut appointment.
Why this is still low? And so I'm with the maximum volume. It shouldn't.
You know, we are working hard.
Okay, well, maybe because this video, and let's just quickly to search if there's another. So, but I have shown this to. I have shown this in my class.
For a round at 12 p.m. No. We do not have a 12 p.m. available.
Is this a different one?
As I said earlier, our vision for our assistant is to help you get things done. It turns out
looks like seems maybe something wrong with my Zoom, probably missing a yes, possibly. So here, okay, so let me see if I can make any changes there, and maybe this one. Okay, so how about now?
Big part of getting things done.
Nope. Okay, so which one? So out. So it's loud, right? And okay, how about if we change to HDMI? No, we cannot hear that.
It's making a phone call. You may want to get
Now getting better, so great. And yeah, let's just watch this 2 minutes.
an oil change schedule, maybe call a plumber in the middle of the week, or even schedule a haircut appointment. We think AI can help with this problem. So let's go back to this example. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
So how can I help you?
Hi, I'm calling to book a woman's haircut for a client. I'm looking for something on May 3rd.
Sure, give me 1 second.
Mm-hmm.
Sure, what time are you looking for around?
At 12 p.m.
We do not have a 12 p.m. available. The closest we have to that is a 1:15.
Do you have anything between 10 a.m. and 12 p.m.?
Depending on what service she would like. What service is she looking for?
Just a woman's haircut for now.
Okay, we have a 10 o'clock.
10 a.m. is fine.
Okay, what's her first name?
The first name is Lisa.
Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd.
Okay, great. Thanks.
Great. Have a great day. Bye.
Okay, so this was what Google had in 2018. Pretty amazing, right? And then, well, I have been a Mac user since 2005, 6, and then back to that time, I was going to switch to a Google phone because of this, but I didn't make the switch, and so they also have another demo, and that one is, I feel it's might be even better. So
Can actually understand the nuances of conversation. We've been working on this technology for many years. Application saying you're
It's for 4 people.
okay, so this one.
than expected. So take a listen.
See how may I help you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people when?
Next Wednesday at 6 p.m.
Oh, actually we leave here for like after like 5 people. For 4 people you can come.
How long is the wait usually to be seated?
For when, tomorrow or weekday or?
For next Wednesday, the 7th.
Oh no, it's not too busy. You can come for 4 people, okay?
Oh, I gotcha. Thanks.
Bye bye.
Okay, so I'm going to stop sharing those. And well, this is what Google had in 2018. So the Google Assistant could also handle the challenging conversation, right? So it looks pretty good, but Google decided turn it off. And I don't know why, but I think it's about the reliability issue. And with ChatGPT, if you follow the news, and Microsoft integrated the ChatGPT into the Bing search, and then so since then, well, at the first few days, there were some interesting happen, and so ChatGPT deleted, so yield with the people who search, and then deleted all the conversation. Also, ChatGPT spoke to one guy, said, well, you know your wife, you don't love your wife, so you need to divorce, and then I love you, you need to marry to me. And then also ChatGPT said, I hate to be here, I want to be a person, I don't want to help people. Yes, if you search in the news and then you will see. So yeah, this all the reliability issue. And then I think just something like this, Google decided to shut it down. And so I got a hand raise, I think. Okay, so no. All right. And so the reason
The progress with the assistant.
no, so the reason ChatGPT got so popular today is I consider it's purely the marketing part. And so, okay, so next thing. So before ChatGPT, another thing very popular was autonomous vehicle. And at least I was very excited about it because before I came to TAMUSA, I had to commute, long distance commute, 2.5 hours for 6 years. Okay, so well, basically I was living in 2 different cities. So during the weekday, I was living in Lexington, Kentucky, but my wife, my home was in Bowling Green, Kentucky, so 2.5 hours drive. So I came home on every weekend, and yeah, I was very excited about autonomous driving, but still until now, we don't, well, we kind of finally have something, but still far away. And Tesla was great in the market, right? So we saw Tesla autopilot, the videos everywhere. And so question, is Tesla the first autonomous vehicle? No. Okay, cool. Yeah, nope. So actually, Tesla, no. And also Tesla actually is far away from self-driving, if you know that. So Tesla has something called full self-driving, or FSD for short. And I think at this moment, consumer may need to spend $15,000 to get this service. Yeah, more or less. And so it's called full self-driving, but from the document, so Tesla provided to the California Department of Motor Vehicle, it's clearly said it is not a self-driving system at all. It's just a driving assistance system. And it's based on the early version of the autopilot Tesla has. And so there's nothing can be considered as self-driving. So again, it's just a marketing point to me. And based on my understanding, so for such techniques, and actually Tesla may not be the best one or may not be the pioneer. So Ford, Hyundai, Honda, Toyota, they all have similar techniques. But also at the same time, the reason they didn't use because the reliability issue. And but Tesla as a startup, it need a marketing part. So yeah, Tesla use market this one. And then here is one more video. I'm not going to show the entire video. And Mercedes actually is the first one brought something autonomous to the US. And it's just happened a week ago or 2 weeks ago. So right now this car is legally driven in Nevada. And they said, okay, California will be the next, but not sure when. And so if you use the something like the advanced driving assistance system before, you know, well, the car handles pretty good on highway or on some situation, but remember that we have to put our hands on the steering wheel, right? And we cannot close our eyes. So yeah, the manufacturer side, yeah, because we need to take control if we need. And then for this one, Mercedes released, well, it has some limitations, so only can drive under 45 miles per hour with the system. And so it's not great, but we could take off the hands and then we could read in newspapers, and then basically the car will handle everything. And then according to Mercedes, if any accident happen, then Mercedes will take the full responsibility to that. So And well, I will just show you a few seconds if I can. Well, looks like I cannot. Okay, so if I cannot, that's fine. So you can Google it, but yeah, but the car currently is super expensive, I guess. I didn't check the price, but my guess is over 100K. And yeah, all right. So we know Tesla. Okay, wow. Okay, will it happen again? Yes.
This button right here, and as you can see, and it literally took over the drive pilot level 3 driving. Sit here right now and do something else. For example, browse the internet. And guys, this is the coolest thing. We all know it. After work, you drive into the traffic and you're already tired. But now you can just start the drive pilot and it takes over the drive for you up to 60 kph. Keep that in mind. And as you see, it's that easy. It's holding the lane, holding a proper distance to the car right in front of you. It even allows people to drive in the lane, and something very cool.
Okay, so yeah, you could, if you are interested, you could search the video, and then there are quite a bit videos on YouTube. Excuse me. And okay, so just have a little bit fun. So a rough guess when the first autonomous vehicle was made. Throw me some numbers. 1980? Nope. Sorry about that. So 82, let's see. Nope. 98. 2000. No. So okay. Well, so actually the answer is 86. So well, you were close. Okay. So the reason I want to put it here because really there's nothing new today. And for autonomous driving in 1986, we had this Chevy minivan, okay, our cargo one, it could drive by itself, 1986. And then also the term of AI. So this figures here shows the history of the term of AI. So the earliest, so we can see there is already has a peak in 1960. So the history could be back to 1940s. So yeah, the techniques we are seeing today was there for a long time, but just due to some reason, and then well, we will get to the reason later, people started to use it. And okay, so, and yeah, this is the very last one. So it's the second version of the self-driving car in 1993. Back to that time, they could do cross-country trip without human intervention. And let's see if I can show this. Cool. Yes. So well, I will just start.
Day at work. Computer puts together the road. Fortunately, Ralph sees what I'm doing, sounds an alarm, and nudges the wheel back in the right direction. When a manually driven vehicle comes, it does all the driving. It is constantly monitoring the position of other vehicles around me and keeping an internal model of what they might do and how it needs to maneuver for safe, defensive driving. When a manually driven vehicle comes up quickly, my car sends an alert,
high-speed vehicle approaching,
checks for open space, and changes lanes to let the tailgater by.
Changing to right lane.
This NavLab is tough. It should be. Its father is an active duty Army scout, the Nav.
Okay, so yeah, in 1997, they already have something at least as good as Tesla, right? And okay, so yeah, aside, so all the techniques are there, but yeah, due to the technical reasons and the cost and the many marketing points, so people in general didn't use that or couldn't. And well, so next thing I want to introduce is just some buzzwords. So well, we heard the term of AI a lot, right? So, and the AI, probably we all know, stands for artificial intelligence, But what is AI? ChatGPT, autonomous driving? Yeah, they all AI, but they are not also not AI, or at least not these two words. And so what do I mean? So AI is actually a huge field, okay? Lots of things we are using today is AI, like we use the search engine, right? So for 10, 20 years, probably already, and that is AI. Then for our credit card, we have the fraud detection system, right? That is also AI. And then for email, we have the spam filtering, so another AI. And then autonomous vehicle, yes, is AI. And so AI has covers lots of areas. And also, like many other things, like natural language processing, so which consider ChatGPT could be, it's AI also. So those great things we are talking about is just a very tiny bit under the umbrella of AI. And I want to point this out because, well, many of you are will be in the technical field. So, well, we need to have a little bit better understanding than the average consumer, right? And okay, so AI, then you heard machine learning, right? And this workshop is called machine learning, right? And machine learning is just one subset of AI. And so basically so we will write the computer algorithm, so program, but we will not tell the program what to do. Well, we will, but not the exact task the program will do. So the program will learn through some data. And so we define how it will learn. Then the program will learn by itself. And then this basically is machine learning. So yeah, I have a few popular definitions from the internet. I'm not going to go through them. So, but yeah, as said, we write the program and then the program will learn from the data. So it's a subfield of AI. And then, well, for my particular research field, it's for deep learning. If you heard the word before, then deep learning is just one type of a machine learning algorithm. And yeah, it's a subset of a machine learning, and then based on the artificial neural networks. And so ChatGPT also mentioned it is a neural network model, right? So ChatGPT is using the excuse me, the deep learning technique to train a machine learning model. And what's the next? Okay, so while this simulates give more explanation of the artificial neural networks, well, the high level idea here is we want to mimic our biology system. And then, so in our biology system, we will have neurons. And then, so the each neuron could gather information and then do some processing and then send the information to other neurons. And then we can do more processing and then so make our biological system work. And then, so yeah, the artificial neural network is really try to mimic that, but still far away from the what we really mean to do. And yeah, okay, so start. Yeah, I can go to next. And okay, so many of you also heard of data science, right? And data science, well, this is tricky, I would say. So lots of things could under data science. And well, one biggest high level idea about data science is data science play with data. Our data scientists play with data. Then what they do, one of the biggest tasks they do is to analyze data, then extract the information, and then finally present the information. So this is one of the major job what data scientists, the people do. So we could consider in this way. So the outcome or the final product of the data scientists, some kinds of knowledge presented to us. Could be PowerPoint slides or could be a report. So yeah, it's some kind of knowledge extracted from data. And then data science people, data scientists will use machine learning and will use other techniques, but yeah, but they most of the time they don't develop the algorithm. And yeah, just to sum, then here shows the relationship between AI, machine learning, deep learning, and the data science. So, well, AI is one of the largest field. Okay, so everything we are talking today, so related, well, at least for this lecture, is under AI, but not everything is under machine learning or deep learning. So, and then, yeah, the differences between machine learning and the data science. So one big thing is different is output. So for machine learning, our output is software which can learn by itself. And then for data science, it's the knowledge. So learned from the excuse me, the data. And okay, so what's the next? All right, so then we will go to a slightly more technical side, but still on the high level. And so you may heard the word supervised learning and unsupervised learning. So how many of you heard supervised learning before? No? Okay, so a few, okay, yeah, pretty cool. So supervised learning is also a big word. So you will hear a lot in the machine learning field. And so this is a learning strategy. So how we can train a neural network or machine learning model in general. And excuse me, basically what we want to do is, remember for machine learning, we need the training data, right? So the model learns from training data. Under like ChatGPT, the training data is, I don't know, terabytes or maybe zettabytes of, excuse me, of text. And so those are the training data. Then for supervised learning, given the data, we want to do something and find some particular outcome. So the machine learning algorithm will find the mapping between those. And so basically give the data, so give the input, and then with each input, we want to have a particular output. Then the machine learning will fill the gap in between. So how to convert the input to output. And with supervised learning, then we need both of the information. So the data and also the output of that data. Just to give you a couple of examples. And well, for instance, in the medical field, we could have a chest X-ray as the data. Then what we want to maybe to find whether there is a lung cancer or not, or could be whether there is this patient has COVID or not, right? So yeah, then the machine learning algorithm will need to figure it out how from the input chest X-ray and then give a prediction of lung cancer or not. And so yeah, the image will be input, and then whether there is a cancer or not will be the output or the label. Then now if we have this, we have the computer-aided diagnosis system for medical field. And one more example. So well, many of you us have a smart speaker and then our cell phones, right? So we could use our voice to control things like play a music or turn on the lights, turn off, right? Then the machine learning, so in this case, our voice will be the input. Then machine learning algorithm needs to analyze the input and then translate the input to some decision. And so with supervised learning, we need to give the model so the data with the input and also what decision it needs to do. So yeah, this is supervised learning. So we need the input and the output of, so the output is also called the label. And yeah, so yeah, supervised learning really needs, excuse me, needs label. And well, yeah, here is also another example. So this is our cat. So yeah, he was small back, young at that time. And so give an image, right? I want to see whether there is a cat or a dog in the image. In this case, if I want to train the model, I need to give the image, and then I need to tell the model whether it's a cat or dog. And then the cat information yes or no will be labeled here. And without this information, the model cannot learn. Just like, okay, so possibly many of you may be able to speak other language, or maybe learned other languages, right? Like I could teach you German. Okay, I don't know German, but I could teach you, and then I will give you. Okay, so here are all the German alphabets. Speak with it's German. There's no way to do that, right? I have to give you the alphabets. I have to tell you how to do that, and then I have to give you examples, and then hopefully you could learn from there, right? And same thing for machine learning. If we only give the image to the machine learning model, it doesn't know what to do, and we need to give the label to guide the machine learning, yeah, for the task. Excuse me. And okay, then for the label, we could, yeah, things getting complex or complicated. Then for the label, okay, so we will have different levels of label. And well, at this moment, we're only speaking the image, and like autonomous driving, it's one of the biggest part is just the image understanding. So have a camera and the understanding whether there is a person, whether there is a car, right? And also, well, they use some LiDAR data. So it's another form of image we can consider. So to train the model, we need to have, well, if we only want to know whether there is a cat or dog, so for each image, I could only provide a label. It's just say cat, dog, or giraffe. That's it. But for understanding the road, excuse me, we need to know where is the other vehicle. We need to know where is the pedestrian, right? So we need to give more information, which could be the bounding box. So which is a box, and then location bound the object. In this way, so hopefully my model will know, okay, at 10 o'clock position, there is a pedestrian. Oh, so 3 feet away from me, there is a car. Hopefully, so with those information, the model can learn that. And then in many cases, we could also do a pixel level prediction. So which means for each pixel on the image, we need a label, but yeah, I'm not going to go to there. And so this is for image. And then, okay, so another big side of the data, actually, so this will be something similar to the thing we are using later for the second half, is called the tabulated data. So, and most of us use Excel before, right? Okay, so yeah, so a tabulated data we can consider is just an Excel table, and each row is one training with one data sample, and so I have some names there. So yeah, okay, so each row is one observation or one sample, and then so we have different columns. So each column is a feature or attributes, right, depending on the field, and then so we could, for this particular data set is for Alzheimer's disease. And then the last column I know is for the, do I have it? I do. So, well, the last column, excuse me, it indicates whether this particular patient has Alzheimer or not. So to train the machine learning model, we want to give all the features here, so except the last one, and then let the model say whether this patient has Alzheimer or not. And hopefully the model will give us the correct prediction. If no, then we will give the model some penalty, and then let the model try it again, and then more penalty and try it again. So yeah, eventually through this process, the model will learn the information related to Alzheimer's. And so, well, hopefully from the second part, you will see how this happen. And okay, then there are also lots of tasks to do. So, well, I will skip a few of those. So well, I will cover this one. So for supervised learning, one biggest thing is called classification. And like whether there is a cat in the image or not is classification task. And then so whether there is a pedestrian in front of me or not is a classification task. So for classification, we have discrete class labels. And so in my figure here, each little dot, each sample could be represent a data point. So it could be an image or could be a voice control. And then so if we project them to 2D space, so each of those will be one training sample. And then the shape will be the label. So for classification, the high level idea is we want to find a model that could separate these two labels. And then, so in the future, if I have some new samples coming, okay, so let's say if we have a new sample like this, and then because our model could separate those two labels, then based on this, the model will predict, okay, so possibly this will be a plus. And then if we have another sample here, then the model will predict possibly this will be a triangle. So yeah, this is classification. Then another is regression. So the differences is for regression, we want to predict a continuous value there. And like the housing market, so give a house, then what is the fair market price, right? So we cannot say good or bad. We need to give a value, and then this is a regression task. For regression, so still each circle is a data point, and we want to feed a model, give us a line possibly, so it will cover all the possible cases. And then so yeah, might be ideally a line like this, maybe better, right? And so yeah, then unsupervised, well, just the opposite to supervised. So there's no label information, we only have data. So unsupervised is hard to do. And just like I said, so teach you German and only give you alphabets, let you figure it out by yourself. So yeah, and this is hard. So yeah, I'm not going to, and well, ideally still, if I have the same samples, but without the label information, ideally, we want the machine learning model to figure it out. And so there are strategies to do. Well, one thing I will just give you one example. It's we could use clustering algorithm. So for each sample, we will compute the distance to every others. And then, so based on the distance, so we could have clusters. So this will be one strategy to do, and then there are many other strategies to do. Okay, so possibly enough. And okay, so well, let's see this one. So what machine learning might or might not do. So, and again, so here, so by machine learning, it's not including ChatGPT, those sort of things. So those things cost millions of dollars, so we don't consider those, okay? And there's no clear answer, but Andrew N, okay, he's my favorite guy. And so he is, what's his position? He's a professor at Stanford also. Okay, so here, the director of a Stanford AI lab. And so I will borrow his definition. Basically, he said he thinks if a task for a regular person, we could, well, or a trained person, we could make the decision in a few seconds, then machine learning can do that. And so if we think of all the examples, right, like chest X-ray to cancer. So a medical expert should be able to do that. Maybe longer than a few seconds, but a minute or two. So they should be able to do that. And then voice control, right? So your younger brother, sister tells you, okay, could you turn on the light? well, it takes us less than a second to make the decision, right? Understand. So all those things machine learning can do. And then this will also go back to the autonomous driving, even though at this moment, not there yet, but this is something I am comfortable we will have it because it's just a second of decision. So whether there is a car in front of me or not, right? I can tell that, and then whether I need to stop or not, I can make that decision within a second. So yeah, this will be something machine learning could do, but the reason we haven't got it yet because autonomous driving will actually include a chain of those decisions. So whether there is a car in front of me, and then should I speed up or slow down? So there will be a chain of decisions, and each of those will be small. So this will be something machine learning will do in the near future. And so this is another example, like diagnosis for the COVID, right? And think about what doctors do in the hospital. And well, they do lots of other things, but just let's overly simplify their job. So they ask, do you have the symptoms? And yes, well, have you have close contact with anyone COVID-19 positive? And yes, well, there is a good chance, right? If no, they will order some tests to verify, right? So each of those just a simple decisions, but it will through a chain of decisions. And then so these other things machine learning could do. And okay, and then so other than that, if it needs us to take a day or two to think and then come up with an idea, then machine learning might not be able to do. And all right, so what I want to go here, yeah, well, I said all the techniques were there, but why we didn't have it, right? Back to the old time. And really we were limited by two things. One is the data, then the other is the computational power. And well, I have this guy, so if you know, he is a basketball player, or he used to be one, and so Yao, and well, just looks huge, right? So yeah, among the regular people. And then so nowadays we really have lots of data. That's why we could train machine learning models. And just an example still from my field, in 2019, the largest image data set we have is this one. So MNIST, and 1998 has 70,000 images. Well, seems a lot, but each image is only 28 pixel by 28 pixel. So how large? I don't know. Probably the tip of my pen, I guess. So, or maybe the bottom. So super small, right? But it was the largest data set we had in 1998. Then 10 years later, we have, remember this name, ImageNet. So 10 years later, we have this ImageNet, and then now we have 1.4 million images. And really, because we have the ImageNet, and then people can start to use train large neural network models. And then we have the AI booming today. So yeah, remember this name. But I'm sure if this group didn't develop ImageNet, some other group will develop something similar. Okay, so yeah, it's just how the field will evolve. But still, well, I still use it a lot, and because it's a reasonable manageable size to me, so 150 gigabyte. But so 10 years later, we have a data size with 18 million images, still not the largest one. Last year, a Japanese group released a data set with 5.8 billion images. Okay, so it's huge, right? And then, so with those database, data side, then yeah, Microsoft, Google can do lots of things, but not us. However, here are some example we might be able to do. So it's I just cropped some images from my former classmate, lab mate. So I think here will be two interesting work he did before. And okay, so this one, because we have the large amount of image, and then he could train a neural network. So given a headshot, and then the network can predict in which city the person coming from. So I feel it's pretty interesting. And then before this, he also did another one, give a headshot. The network predicts so roughly which year, 1950 or 1969, and then the image was made. And also, so he is a applied scientist at the Zillow. Yes, I think it's applied scientist. And this is the really, I think this is one of the major work got him to Zillow. And because, well, this task doesn't make sense at all. Okay, so if we don't thinking about the big data machine learning, what he did is he used the facade, so front view image of houses without any other information, without the square footage, without the age, without the number of rooms, and then he was able to predict the house price. So yeah, without a large amount of image, I would say those works doesn't make sense, right? But yeah, this is what happening. And okay, so well, let me show you one more story, and then we will go to the technical side. And well, I said, but still adopting the machine learning or neural network in real world is hard. And so one big reason is the we call it calibration from the field, which is the model really have good performance. So 99%, 98% of accuracy. So this is true. However, the model also overestimate its confidence. This could be a problem. So let me give you an example. And so, okay, so well, I ask you a question. So let's see, can you recognize, so if I have a mask on, can you recognize, so the person is me? And then you said, yeah, so someone, you said no, some said, yeah, possibly. And then I ask you, so what is your confidence level? Then someone said, okay, 70%, I guess. Okay, so then, which means, but if you give me 70%, right, confidence, which means if I ask you 10 times, or I change 10 masks, so there will be 6 to 7 times or 8 times you could get it correct, right? And if you tell me 90%, then I would assume, yeah, you may only get 1 time wrong. And so oppositely, so if you get 1 time wrong, 9 times correct, so I assume, yeah, you may have 90% confidence for each guess, right? But this is not what happening with machine learning. And the machine learning, the confidence is super low in many cases, maybe only 1% of confidence. Yes. So I saw some faces and yes, but yeah, it could get the thing correct. However, there will be an issue. So this is a story happened 2 months ago in China. So China really has lots of well, the companies are eager to use the latest techniques. And so there is a vehicle and it could detect the pedestrian, cars, and then any other things around the vehicle, and then show, yeah, have a nicely animation there. But this, so we see a person, right, behind the car. But the issue with this picture is it was 2 o'clock in the morning, okay? And it was a raining day. This guy was driving on highway, and then we can see the speed not very fast, but still 62 kilometers per hour, so 45 miles per hour. And then there is a guy running behind you. So were you scared? And then, well, this driver was scared to death. He checked the mirror, there was no person. Okay, so of course there's no. And then, but it's just a one little thing that machine learning got wrong, because yeah, it has size this person, but it has low confidence. And then so with cameras, so during the rainy day, it's really mess things up. And similar thing was happened to Uber also. I think it was 2018. So Uber had the first kill in Arizona. So the Uber, autonomous driving Uber, actually killed a lady there. And so later they found, well, the car didn't stop, just go to that person. And then later they found, actually the car did detect that person, okay? But the car didn't recognize, so it's just an overconfident, thinks that it's a balloon, not a person. And then because it's a balloon, so the car could hit it. And then actually kill the person. So, okay, so it's enough so for the story. So yeah, that's why, back to very beginning, so it's one of the reasons why many big automobiles are kind of conservative on autonomous driving, and also could be the reason why Google removed the Google Assistant. And okay, so well, it's enough. Let's go to the technical side. And do we want to take 5 minutes break? No? No? Okay, that's fine. Yeah, that's fine with me. So well, let's go to the technical side. And well, I will show a few slides. And well, I'm not going to cover all of those, but a few, then we can write some code. Okay, so well, linear regression, it's really the thing I want to introduce. So given some housing price, a data set like this. Okay, so well, I'm sorry, I have to reshare because I need to draw here. So give a data set like this, then ideally, do I have it here? Yes. So ideally, we want to feed a linear regression model which predicts the real value. And so what we have here is the x-axis is the square footage of a house. And then we only assume we have the square footage. Then the y-axis, excuse me, is price. And then each of the little cross is one house. For instance, so this particular one, if we go to the x and go to y, so we can figure out, so the square footage is around, I guess, 800 square feet. Then the price is a little bit below 200K. So this is how we read a figure like this, okay? And then, so another example, this one, so we can find the square footage and then price, right? Close to $500,000. And then, so ideally from here, we want to feed a model. So we already simplify the model, which we want to find a straight line. Okay, so given the straight line, so if we gave, based on the straight line, if I gave a house with 3,000 square feet, then I can find the corresponding value there. So this is a linear regression. So we want to feed a line that can give us the real value output. And then of course for real, if the model needs to work well, possibly many times we may need to have some curves, right, or other shapes. So we could do that. But for start, we assume we always want to get a straight line, okay? And then, yeah, so we want to get a straight line, and then if you take the from your math class, we know this is a straight line function, right? So given any x value, so I can I can multiply it by a value a, then plus b, so it will be the output on the line, which is the y value there, right? So then to fit the straight line, I just need to figure out what is the a and the b. So what is the both the a and the b? And so all this number will be learned from our model. And well, says a few notations here. So because the task is given the size of the house, and we want to predict the price. So the size will call the input, all the features, and then the price will be the output, all the target. And okay, so yeah, then the task we want to do is to again figure out A and B here, right? But with machine learning world, we don't use A and B. We use the parameter theta. So we will have theta 0 and the theta 1. Well, basically it's A and B, just different names. And we want to learn thetas. And the theta is used for machine learning world for parameters. And okay, so yeah, ideally the model will give us different with different theta, so we can have different model or different result. Let's say for theta 0, if I have the let's go to the only the very first. So if my theta 0 is 1.5, theta 1 is 0, right? And basically given any x, it will be the output will be 1.5, right? So my model will look like this. I think I got it correct. And then so with another side of theta, so theta 0 is 0, theta 1 is 0.5. Then if my x is 1, the output will be 0.5, right? If my x is 2, the output will be 1. So it will give me a line like this. Right. And then one more example. So if my theta 0 is 1, theta 1 is 0.5, then okay, so I need to think about that. So 1, if my x is 1, the output is 1.5. If x is 2, oh, I'm sorry. No, if, yeah, x is 1, yeah, 1.5. Then if x is 2, then the output is 2, right? And then so I will have a line like this. So really, if I can figure out that the given a data set, if I can figure out that the theta 0 and the theta 1, I will have my model. Then how to do that? Well, one thing is we need to be able to measure so which model is good. So we need to know whether my current model is bad or not. And then from there, we can learn, right? Just like many of you had my midterm exam last week, right? So if you got 80 and then, yeah, okay, so, but you know where you want to go, right? So same thing to the machine learning. And so then we need to decide which one is good. And well, suppose I have two lines like this. So the blue one and the orange one, which one is better? Any blue one? Okay, why? The orange one perfectly gets this point, but why blue one is better?
Because the margins how close the line is, the actual points is better on that one.
Okay.
For all three of them, it's relatively close, whereas
Yeah.
the yellow line, sure, it exactly hits the second point, but it is nowhere near as close to the first and third one.
Cool. Yeah, it's a good argument. So yes, and but to neural net machine learning models, we cannot give this argument. Well, yeah, actually it's correct, but we need to translate this to something the model can understand. And then so basically we will do the same thing. We measure the distance Okay, so we measure the distance. So this is between the blue line, and then let me change the color. So this is between the orange line. So we measure the distance, and then we give the distance back to the model. Now the model knows how much I miss from my target. And so yeah, just like what he explained, but we need to translate that to something the model can understand. And then so how to measure this will be called the cause function. And well, I'm not going to go through the equation here, but well, I guess I have to a little bit. Sorry about that. So yeah, the top line is our model. We want to figure out the theta 0 and the theta 1, right? And then to measure, so this is the equation to measure. And what we do is to take any input, then h of x, h of theta is our model. So give the input to the model, model will give us our output. Then we compare the output with y is our ground truth, the target. And essentially we does something here, right? So measures that, and then but we use the equation and the cause function to do it. And cool. Then I cannot remember. So yeah, now it's the learning happen. And so still how to learn, right? And now we need to reduce the problem, so make it even simpler. So we only consider one parameter, okay, for the demonstration, and then we only need to figure out the theta 1 here. And all right, so what machine learning does is it actually starts with some point, and then just give a try. That's it. So well, if we have only one, so let's say maybe my theta 1 will be starts with, I don't know, well, maybe 0. Now I have a line like this, right? Then I can measure the distance. So here will be 1, 2, 3. And then I put in the equation. So I believe, so that equation called the mean square MSE, mean square error. So for each one, I will take the square and then calculate the mean. So if this one, now my mean square is so 1 and 4, so 14. 14 divided by 3 is 4.6-ish, right? So okay, so let's say 4.6. Okay. Then so now we know how bad it, and then so on the right side is a figure, so shows the cause function. So we can start to build the figure here, and the x-axis is my value of theta 0. So theta 0 is theta 1 currently is 0, right? And then the y is the cost. So it's 4.6, and where is 4.6? Well, so 3, 4 is here, 4.6 is here. Okay, so now my first cost is here. Okay, and then well, let's take a random direction. So whether we want to increase x or reduce or minimize, and then let's say, so maybe this time I will change my x, I mean the theta 1 to 0.5. And okay, so what we have, 0.5, I will have my x is 1, then so 0.5, and then here will be 1, and then so now if x is 2, is 3, oops, go back, okay, x is 3, then we have 1.5. Now we have a line like this, right? And then again we measures the distances here. And so let me quickly calculate. So it will be 0.25, and then so 1, then okay, 1.5 times 1.5 plus 0.25 plus 1, 3.5 divided by 3, Okay, so 1.16. Now we have 1.16, well, 17. Okay, well, let's say 1.2. Okay, so now my theta y is 0.5, right? And then my cos function is 1.17. So 1.17 possibly here. Okay, and then so let me do one more. So if I keep increasing, so seems if we draw a line there, so we can see it's reducing, right? So we are doing going to the right direction. And then the model will, okay, so I will keep increasing the theta value, so to 1. And if we have it as 1, so we will have a perfect line there, right? So go back to the right side. So my theta is 1, then the cos is 0. So we keep reducing, okay? And then most of the time it will be a curve. And then if we keep trying that, so actually it could going up. So yeah, we will build a curve like this. And then if we could build a curve like this, it will easily clearly show us where is the minimum point on the cos function. And then so from the minimum point, it will tells us the best theta. So this is actually what happening so on the learning side. So we start with some random point. Well, yeah, most of the time people may start with 0 or 1, and then get one attempt. So the next time, so either increase or decrease a little bit, and then try the next time to see whether we are going to the right direction or not. And so actually there is an algorithm. I'm not going to talk in detail, but it's called gradient descent. So gradient descent could help us to decide which direction to go, whether I want to increase or decrease. And so back to here, this is if we only have one parameter, so one theta. When we have two thetas, do I have it here? And then the cos function will be a bowl shape, two-dimensional shape. And so in this case, we'll get complex, but still following the same theory. So we just try theta 0 and the theta 1 with different values, and then to see whether the line goes to the correct direction. And so with some even higher dimension, we may have the cos like this also. So then the idea we want is to start with some point, and then so hopefully we can just keep reducing it, reduce, and then until to the lowest point. And but like a function like this, it's possible we may go to another lowest point. And then so yeah, so then which this shows you, and it's also true when you train the model 2 times or multiple times, you are not guaranteed to have the exact same result. Most of the time it will be close enough, but not guaranteed to have the exact same. And all right, so and okay, so this is the equation. So if we write the program from scratch, and this is the equation how we can update the 2 parameters. And basically we just plug in everything here. And so remember, this is the output of our model. This is the label value. So we compute the distance before there. And then so alpha is a parameter we select, we call it the learning rate. So yeah, no, it's just a scalar, so a small number, 0.1 or 0.01, or sometimes most of the time, I'm sorry?
No, that is like, I heard that this is like epsilon, like the,
yeah.
similar to the epsilon, like
yeah, well, no, not really. So the gradient descent will, so if we go back to here, so the gradient descent will decide the direction for us. And then the alpha will decide how large each update will be. So yeah, and then if the alpha is too large, then so we will reduce fast. However, we may miss the lowest part. But if alpha is small, we will just too slow. So yeah, and yeah, this is one thing we need to decide, and then through experiments most of the time. And okay, so I think now we have enough background for the gradient, for the linear regression, and then actually let's play with it. So possibly I don't know if I can have both of them, but I can at least have one. And so I will use my Colab. Colab is just the Jupyter notebook. And what I'm going to do is to build a linear regression. Yeah, I think I want to build it from scratch. So yeah, so I can clearly show you what is happening here, and then import ACM-TAMUSA. So, and then I will also import a few libraries. matplotlib.pyplot. Okay, so it just import some libraries. NumPy is used for scientific computing, and the matplotlib is for the visualization. And okay, so well, I will create a dummy data. So without array, and so I will create a data set 0, 1. Okay, so it doesn't make sense at all, but so it will be a 2 dimension. So 1, 2. Don't. Okay, so don't give me that. Okay, 3. Okay, I will remove that later. So 3, 4. Okay, so now assume we have a data set. So have 4 elements, and then well, the first one is the input, then the second is the output, the target. And so if we plot the data set, it will look like okay, so I go to data and 0, y equal to data colon 1. So yeah, now I am getting the first column of everything and save it to X, and the second column of the data, and then save it. Okay, so yeah, save it to Y. And so let's plot. Okay. So this will be our what the data set look like. And so my X label is yeah, is input. In okay, so now it's clear. So my X is the input feature, the first column, then Y is the target. And then ideally I want to fit a model. So given any possible input, it will give us the good output, good mapping. So yeah, this is our goal. And then well, what I need to do is to build the okay, so I think I can finish it. So I need to build the model. So linear regression. Then so we will give input, and then theta and the input. What we want to do is to predict. So it will be equal to theta 0, then plus theta 1. Well, yes, let's do that. then times input. So now I am having a straight line function. So with two parameters, theta 0 and theta 1. For any input, I times that with theta 1, then plus theta 0. So it will give me the output. And that's it. So this will be my model. So return predict. So this will be my model. Then next thing, I need to given the model, I need to compute the cost. So compute cost. And to compute cost, I will need two things, y predict. So the output of my model and then y true. So the ground truth label. And then, so well, I need to, well, I will just go ahead, type the equation there. So yes, length y true, then j equal to 1 over 2 times m times np dot sum. Okay. And then so I need to be careful here, y predict minus y true square. Okay. All right. So, well, basically take any prediction and then compute the distance from the target, then compute the square, and then sum everything together, right? And then divide it by 2 over m. So the average, so get the average mean square, right? And mean square. Okay, so this is cool. And then the last one, so define update. So how to update theta, and the update theta will be using gradient descent, which is this here. And so I will just show it here. So then I need a few. I need, yes, I do. I need a few things. So m equal to still length y true. Okay, so well, I need more input parameter. Firstly, I need to give theta. Theta, then I need x. Do I need x? No, I don't need x. No, I don't need x, but I need a y. Predict y true, and also I need a learning rate. So which is the alpha. So then, so back to the equation. So it will be theta 0 equal to theta 0 minus learning rate times 1 over m. So well, again, it's just the differences. So np dot sum y predict minus y true. Okay, and so learning rate times. Okay, yeah, this is for theta 0, and then theta y, we need to have one additional equation, and I will just fix it here. So learning rate times 1, then times. Okay, so I think this is the thing I need to do. So times x. Oh, I do need x. Yeah, I can add x there. So the input feature. And let me make sure. Okay, so yes. So for the differences, and then we multiply x, and then do the sum. Yes. All right. So this will be the, excuse me. So this will be our theta. Excuse me. And then now we have everything. We have our model. So given the theta value, we can make a prediction. Then here is we can compute the cost, so how wrong it is. And then, so here is how we can update the theta. And just as what we have seen, we will start with something. And so let me run this cell, then theta equal to 0, 0 start. Many people will start with 0 or 1, then learning rate equal to something small. Okay, so now we can start training. So for, excuse me, I in range 25. So I have a for loop. The for loop will run 25 times. And for each time I need to train the model for 1 time. And then predict equal to linear regression. Excuse me. So with linear regression, I gave the theta and the input. Theta and x is my input. Cost equal to compute cost. No, I don't need theta, but I do need the prediction. And then y. Okay, so now I have the prediction of the iteration, then the cost, and so after that I can update theta. Theta x and well, I need to go the particular. Okay, so predict y and the learning rate. So LR. All right, cool. So now basically this will be my how the model will learn. So just start with theta and then try a little bit, compute the cost. Based on the cost, we update theta. And so, but yeah, let's have some plot the figure. So what I want to do. So I will use a plot. So 5, 5, and I plus 1. Okay. So PLT scatter x, y, and yep, that's fine. Then so now for each time, so I create a new figure, a sub figure, and so I firstly plot all the data there. And then next, I need to plot a line to indicate the model. So for the line, I will just assemble a bunch of points between 0 to 4, I guess. So temp input equal to will be a numpy array, and then for I in range length y. Okay, so now I assemble a bunch of points between the 0 and the 4. And temp predict. So I feed this one out of those to the model linear regression, and then temp input. And also, yeah, I need to have give the theta there. So based on the theta, we can do the calculation and then plot plt dot plot, and then okay. And so let's run the code. Okay, so well, okay. Well, it's the figure is small. So yeah, let me make one more change to make the figure larger. So what I want to do. Yeah. Figures 30. Okay, so let me run it again. All right, so now we can see our model, how it learns. So initially, because we start with zeros, right? So after the first time, the model is basically close to horizontal. And then, but it getting there. So yeah, based on the cost, it's getting closer and closer. So after, yeah, each figure is plot for one training, okay? And so we call it one epoch for one training. And then after 25 training epochs, so the line is getting closer to the data. Yes, sir. The input, yeah, here. So yeah, this is just a bunch of points. So random here. Yeah, so just some dummy values there. And then so by adjust the learning rate, so if we change it to 0.1, then yeah. Okay. Okay, sure. So yeah, if I increase the learning rate, then my model will learn faster. And then, so after several tries, so the model gets close to the point, right? And okay, so eventually it's pretty close, but still not 100%. And so this is how the model learns. So just through iteratively, yes, sir.
Are you able to variably adjust the learning rate? Like,
yes.
If it sees that it's very off,
yes.
You like variably change?
Yes, yes, you could. And with many libraries, there will be functions to do that. And there are also different strategies to do that. And yes, you could. And yeah, and also, so if we write from scratch, you could have an if statement here. So add the condition and then change. Yeah, you could do that. And okay, and then, well, it's almost the time I have. So I apologize, I cannot go to the second example. So yeah, but I will go to the second example next time. Sounds good?
Could you go back to the definitions of to the function?
Yeah. Sure. Yeah. You're welcome. Okay. All right, so, well, if you give me 2 more minutes, okay, so I do want to show you why I am particularly interested in talking about the linear regression, because we will I will cover those later, but because there is something called logistic regression. And basically logistic regression is just convert the linear regression output to something between 0 and 1. Okay, so where do I have? Okay, I don't have it. So yeah, convert so we will feed a linear regression model, but it doesn't work here, right? So we need to convert the value to 0 and 1. So we could put the linear regression model inside of one function called a sigmoid. And then, so, well, it's just some mathematical function. After that, we will have 0 and 1 function. And then actually, if we go to the, well, so possibly I need to go next week. But if we go to, well, I don't have it here. And then here are lots of neural networks. And then each circle, okay, is one neuron. And then each neuron is one logistic regression model. So that's why I want to cover linear regression and the logistic regression. So yeah, we will talk about those next time. And okay, thank you very much. So yes, of course, thank you. I will stop sharing and
anyone wants to come pizza? I think might be a little bit cold for the feel free to take some pizza, some drinks as well.
Okay.
Which one would you like?
Oh, this one. Thank you very much.
You're welcome.
Thank you.
Thank you. I really,
Oh,
really appreciate it.
yeah. Well, I like to do things like that. Yeah.
That's awesome.
Okay. All right. Sure. Yeah.
Thank you.
ACM is going to be able to tour the new building. So in order to be part of that, join, if you're not already, join in the ACM Jackson, become a member there. And then once you're a member, you'll get the emails that we send out. We're going to be sending out an email of whoever's interested in touring the building. We have, I believe, max of 30 spots. So as soon as